So, have you done these questions, Tabiano, from exercise 111C, 3, 5, 6, and 7?
Um, I think we did through. No, we didn't do any of those. No.
So,
We did 1, 2, and 4.
can you do 3? 3 is easy. It looks easy to me.
I can probably do 3. Yeah,
Sorry?
I can probably do 3. Yeah.
So, let's do 5.
hmm
So, he says that by expanding sine 3x plus 2x and sine 3x minus 2x using double angle formula, or otherwise show that sine 5x is equal to 5x plus sine 3x is equal to 2 times sine 3x and cos 2x. This is part A.
hmm
How can we show this A part? We have to show that sine 5x plus sine x is equal to identically equal to 2 times sine 3x cosine 2x. Means this is an identity. We have to
hmm
prove this.
hmm
How can we prove this?
What does it mean by expanding?
Hmm. He says that by expanding you can prove it.
Uh-huh. Oh,
Or
3x plus 2x is just what 5x, isn't it? And then.
yes, this is actually when we convert sum into product, we use these
hmm
identities. You can see on left hand side there is sum of two sine functions,
hmm
right? And on the right
Yeah.
hand side there is a product. So this is
hmm
converting sum into product. I don't know how can you do it by expanding these in using double angle formulas. He says, or otherwise, you can use any other method as well. So converting sum into product, yes, yes, of course, we can do it by expanding these two formulas actually. So let's do expansion.
hmm
Expand sine 3x plus 2x by using this formula. Sine alpha plus beta is equal to what?
Um.
Sine alpha cos beta
Oh, and then sine beta
plus
because alpha. Yeah.
sine beta cos alpha. So let's expand it.
But can we not
Uh,
just
sorry.
see the 3 and the 2 and just add it to 5x? Or is that?
Yes, we will add them to 5x and we will get the left hand side, right? But what about the right hand side? Let's expand
Mm-hmm.
sine 3x cos 2x plus sine 2x cos 3x,
Oh,
right?
I see. Okay.
Similarly,
Uh-huh.
let's say this is equation 1. Let's expand the second expression, second
hmm
sine function, 3x minus 2x. So this will be, again, we will use sine alpha minus beta formula. Sine alpha cos beta minus, we have minus in this formula, sine beta
hmm
cos alpha. And say this is equation 2. Now, what we will do to get this identity, number 3, what to do? To add equations or subtract equations?
Add the equations, right? Because it's a
Why?
plus, yeah.
Because there is a plus sign. So we will add them. So now
hmm
you can add, yeah, no, you can put
Yeah.
sine 3x plus 2x will be sine 5x plus
hmm
3x minus 2x will be sine x equals to, now
Uh-huh.
when you will add them, these terms will be cancelled. So we'll be left with
Oh, yeah, of
sine
course.
3x cos 2x two times. So this is 2 times sine 3x
Mhm.
cos 2x. So we have proved this identity.
Oh, and that's the proof done.
Uh,
hmm
What is
I see.
next now? Uh, we have to we have to find this integral. Now, whenever you get these type of integrals, when there is a this type of product of sine and cosine with a different
Hmm.
argument, they are not with the same argument. If it was 3x here and 3x here, it would be done with a
Hmm.
different method, and that is easy. If we have, for example, we have sine 3x and cos 3x, then what you will do? We already done this.
Take a half
Sorry?
out and then make
Ah,
it 2 sine x cos x. You take out the factor of a
x.
half, make it 2,
And exactly. So this will be double of the angle,
and then
like this. And this is cos,
mhm,
negative cos
mhm. Yeah.
6x over 6, right? So what about here? Here we have to convert this product into
Yeah.
sum. This is the idea. So convert this product into sum. Can you hear me properly?
Uh-huh.
Or should I change my connection?
Yeah, yeah, I can.
Okay.
No, it's okay.
So let's use the identity which we have proved in part A to find this integral. So this integral will be, what was that? Sine 5x plus sine x. We have just proved that
Uh-huh.
this is equal to this. Now we will,
Oh, yeah, of course we did. Yeah.
yes, we will integrate separately. This will be uh, cos 5x over 5 negative and negative cos x. And you are done.
Mm. Yep.
Okay. What about the next one? Number 6. This is also very interesting.
Hmm.
Let's
Yeah,
add
the
to the
last one's
new
quite
page. We will discuss the last one. Let's see this one. We have to show that we have to show that f of x is equal to cos 2x plus 6. Given is 5 times sine square x plus 7 times cos square x. I can rewrite it as, how can I rewrite it as?
um
6 times sine square x plus 6 times cos square x. Let's break it like this. So we will be left with a
uh-huh.
positive cos square x and a negative sine square x.
Oh yeah, and that can just be 6 times
Yes,
1, right?
exactly. This will be
Uh-huh,
6
I
times
see. Yeah.
1. And this is a double angle formula of cosine. I already told you that this is equal to cosine of double x, cosine of 2x. Sorry.
Oh yeah, yeah,
So
of course.
cosine of 2x, and this will be, this is done. This is this is exactly the
Oh
same which
yeah,
we want to prove. This is cosine 2x plus
yeah. Hmm.
6. Hence find the value of the this integral from 0 to pi by 4 in b part. So integrate this from 0 to pi by 4. The given function. So given function is now simply this, and we know we can integrate this
Hmm.
easily. And this is going to be
Yeah.
sine 2x over 2 plus 6x, and we will put the limits 0 to pi by 4. When we put pi by 4, this
Hmm.
will be sine pi by 2 divided by 2 plus 6 times pi by 4. And when we will put 0 in both the terms will become 0
Hmm. Hmm.
because sine 0 is 0. Sine pi by 2, what is its value is 1.
Yeah, yeah.
Sine pi
I
by
remember
2
that
is
one now.
1. So no problem. So this is
Yeah.
3 pi by 2. This is the exact value of the given integral.
Mhm. Yeah.
Uh, the last one, let's add to the new page. And this is also in two parts. In first part, we will uh, decrease the degree as I already told you, then whenever there is even power on sine and cosine, either power is 2, 4, 6, or 8, we will decrease the degree of the that function actually. So after
Hmm.
decreasing the degree to 1, we will have this. So let's do part A. How you decrease the degree? We have formulas. We have this formula of degree reduction, which you can call a double angle formula. Cos square
Hmm.
theta is equal to 1 plus cosine of 2 theta divided by 2. This formula will be used. Okay.
So do you use cos squared theta squared and then
Yes. So cos square
square
x
root?
whole squared, and we will put the formula
Mm-hmm.
inside 1 plus cos 2x divided by 2 whole squared, and then
Hmm.
square the numerator and as well as denominator. We have two terms in the numerator, so we will use formula a plus b whole square. 1 square plus 2ab means 2 cos 2x plus square of the second term cos square 2x divided by
Uh-huh.
4. Do you have
Yeah.
any questions or clear?
No, no, that makes sense.
All clear. So still we have power 2 here. We have to reduce the degree
Yeah.
again.
Once
So we
again.
will put once again, yes, we
Yeah.
will put the formula again. So cos square 2x will be equal to 1 plus cos, you tell
Cos
me,
4x.
4x.
4x. No.
Angle will be doubled, means
4x.
divided by 2,
Yeah.
whole divided by 4, like this. Now we will just simplify this, taking LCM in the numerator, and that LCM 2 will be multiplied with the denominator, making it 8, and this 2 will be multiplied with 1, 2 plus 2 to the 4 times cos 2x plus 1 plus cos 4x will be same. Now let's just
Mhm.
rearrange these terms. Uh, how it is arranged, we will arrange in the same way. Cos 4x is the first term, so we will put cos 4x as the first term, and 4 times cos 2x is the second term, and 2 plus 1 will give us 3,
Mhm.
and divide each the term with 8. So divide this by 8, divide this by 8, and divide this by 8. So this will be 2 cos 4x divided by 8 plus cos 2x divided by 2 plus 3 over 8. Uh, Proved. This was the right hand side. You can see.
Mhm. Yep. Mhm.
Now, uh,
Yeah,
it
that makes
is
sense.
easy. It is easy to integrate in the B part. We want to integrate cos 4x. We cannot
Mhm.
integrate directly because the derivative of cos 4x is not present here. We cannot integrate. Therefore, we have to reduce the
Mhm.
degree. And we already reduced the degree. We will put the expression which we have got for cos 4x. After putting this expression, now we can integrate separately each of the terms. So cos 4x will give us sine 4x divided by 4 8s are 32 plus cos 2x.
Mhm.
Antiderivative of cos 2x is sine 2x divided by 2 to the will give us 4, and 3 over 8 same antiderivative of 1 is x plus c, and done. Any questions?
Yeah.
Yeah. What?
No, that makes sense.
No.
No, we're good.
So all is done, I think.
Mhm.
Let's move to the next part. Section 11.4, you can integrate these type of functions very easily. I already told you that
Yeah.
whenever there is a function in the denominator and its derivative is present in the numerator,
Yeah.
its integration is simple. Simply log of the function,
Yeah. Yeah.
natural log of the function plus c. This is the formula which we will use in this section, and you just have to see that the derivative is present in the numerator or not, or you can
Yeah.
make the derivative completely. So let's do part A. It's 2x divided by x squared plus 1. So what is function here in the denominator? X square plus 1.
Um,
What is the derivative of
yeah,
x square plus 1? It's 2x.
2x. Mhm.
So simply you will write that the antiderivative is log of x square plus 1 plus c,
Mhm.
nothing else. Similarly, in part B, the antiderivative of cos x
Yeah.
divided by 3 plus 2 times sin x. What is the derivative of the denominator?
Um, just cos x, is it not?
No, no, 2 cos x.
Wait, do we
Derivative
lose
of
the two? Yeah, yeah, we do.
3 is
Yeah,
0.
so just
Derivative
cos
of
x.
this is 2 cos x. So 2 is
Oh,
missing. 2 is missing,
mm,
right? So what we will do, we will divide 2 outside
yeah.
and multiply 2 inside. Because it is a number, we can take it outside and inside. It will not make any trouble for us.
I see.
So now you can see
Mhm.
the formula is applicable. Derivative of this whole is present in the numerator. And you can just say that the
Yeah.
antiderivative will be the log of absolute of 2 times 3 plus 2 times sin x. That's it. Any questions?
Oh, no, that makes sense.
Clear? Okay. What about this? Now you can
Hmm.
use uh, this is called general power rule whenever you want to integrate any function raised to power n.
Hmm.
Like if you want to integrate x power n, any power n, how will you do it? X power
Um,
n.
x to the n plus 1 over n plus 1.
Yes, exactly. But what if there is any other function like x square plus 1 whole power 5? How to integrate this? The same way or not?
Uh, no, because you have to multiply the derivative as well, right?
Yes, exactly. Here we should have the derivative, means 2x should be present here. If 2x is
Hmm.
present, then you can integrate the same way. Just add 1 to the power and divide by a new power.
Hmm. Hmm.
Okay. So similarly, generally, if we write, if we have function power n raised to power n, then the derivative should be present here. If derivative is present,
Uh-huh.
then we can simply integrate the same way. Okay.
Hmm.
So here we will use this formula. This is
Makes
called this formula you can call it general power rule.
okay.
General power rule. And this formula is known as simple power rule. Simply power rule. This is power rule and this is general power.
Hmm.
Okay, let's see how to apply this. In part A, we have 3 times cosine of x sine squared of x dx. So you have to see which function is raised to some power. Sin x. Sin x is
Sine
raised to
x
power
squared.
2. Yes. So we will put sin x
Hmm.
first. Sin x squared. I can write it like this, sin x squared. And tell me what is the
Hmm.
derivative of sin x? What is the
Cos
derivative of sin
x,
x? Cos x. So cos x is available here. So
right?
I will put cos x here. What is the role
Yeah.
of this 3? Nothing. So you can
Hmm.
take it here outside. Now it is just like this,
You,
right?
mhm.
Function inside some exponent and derivative is available outside. So what we will
Yeah.
do, we will just add 1 to the power and divide by a new power. That's it. So the availability or presence of this derivative is important.
Yeah.
It's important to have derivative here. If we have derivative here, then we will just increase the power by 1 and divide by that new power, new exponent. That's it. 3 will be cancelled and the answer
Hmm.
is sine cube x plus 3. Any questions?
Hmm. No,
Yes.
that's clear.
Okay. I'm just doing it quickly because I have another class next. So let's do it
That's fine.
below
Yeah,
here.
no worries.
So this is easy, I think. You see, thus the presence of the derivative is important. If you see
Hmm.
the derivative is
Yeah, yeah, yeah.
inside, what is the derivative of the function inside the exponent? It is 2x.
2x, yeah.
So 2 is missing. So we will divide by 2 and multiply 2 inside. Now you see the derivative is available. We will just increase the power by 1 and divide by a new power. You see, what is the role of this presence of here?
Hmm.
Presence of the derivative is important. It has no further role to the next term.
Yeah.
It is not coming to the next term. Just its present
Mm.
is important, right?
Yeah. Yeah, yeah, yeah.
Do you can you hear me properly?
I can.
Okay. So this one is also same. I want you to do this, solve this.
Okay. 2 plus cot x. Okay. Okay, so at the bottom we have 2 plus it's x squared x. So you have so it's just hang on. So f of cos x squared x over 2 plus cot x is the same as um then
There is a power 3 in the denominator.
oh yeah, yeah, of course, of course. So it'll be what? Oh, does that? Oh, that must work differently then. Um,
No problem. You can just
or do
erase
you
this.
just leave it as that?
Sorry,
Uh-huh.
what is you
Do
don't need to
you
erase all.
then? What do you do with the power?
You take it into the
Oh,
numerator.
sorry. What do you do with the power? What do you do with the power?
Take it to the numerator. Power will be negative. Take it to the numerator.
Oh, yeah, of course, of course, of course.
I am changing my connection. I
Six
think it is having some trouble.
times. Okay. This is after x equals um. Is that correct?
Ah, yeah. But there is one mistake in this. Uh, the
Oh, is
derivative
that?
of cot x is negative cosec square x, I think.
Oh, it's negative cosine. Yeah, right. Oh wait. That. So it's negative. This.
Yes, yes.
Okay.
Okay, done. Let me do it. Let me write it. Please allow me to change my connection. Give me a second.
Yeah, that's fine. Yeah, no worries.
Hello.
Yep.
Can you hear me? Yes.
Yes.
So you will just write like this. You should just write it like this. Take the power to the numerator.
Mm-hmm.
You should, together with knowing everything, you. So sorry, there was some problem.
That's okay.
So I was saying that together with the knowledge of everything, you should also learn the art of writing also.
Uh-huh.
So you see, I said, what is the function inside the exponent? This is the function, right?
Mm-hmm.
So what is the derivative of this function? This should be present here. Is it present
Yeah,
here?
it's negative cosec squared. Yeah, kind of,
What is
almost.
missing? What is missing? Something is missing.
-1.
Negative sign is missing. So we will multiply negative sign, negative 1 outside and inside. So the
Mm-hmm.
derivative will be present then.
Oh, and it's -3 as well, not.
So now when the derivative is present, yes, this is minus 3. Thank you.
Mm,
Now when the derivative is present, what you will do, you will simply add 1 to the power, 1 to the
yeah.
exponent and divide by the new exponent. This is the rule. So this will be
Oh,
negative
yeah.
2 plus cot x whole power negative 2 divided by minus 2 and this will be plus. So
Mm-hmm.
the answer should be 1 upon 2 times, let's take the whole to the denominator and
Mm-hmm.
this is the answer.
Yeah.
All right, this is the last question we will
Mm-hmm.
discuss and then we will do exercises in the next class.
Okay.
Okay, solve. So you have
Right.
to find the value of theta here. Given
Mm-hmm.
is the integral is equal to 15 over 5. This is given. So
Yeah.
take this given and find theta.
Mm-hmm.
So start with what is given.
Yeah. So what's given is 5 tan x times sec 4 to the power x. Okay, and this can be written as hang on, as sec squared all squared because the derivative of sec squared is tan, right? So if we take the 5 outside and get rid of the 5 here, and
What is
then
the derivative of sec square?
tan x is not.
No, no.
Oh, is it the other way around?
It's the other way. It's derivative of 10x is sec square x.
Oh,
Yeah,
huh.
yeah. What is the derivative
Hmm.
of sec x? What is the derivative of sec x?
Derivative of sec x is sec x tan x.
Yeah, yes. Do it
Oh,
this way. Yes.
okay. So then you have. Oh, interesting. Okay. Yeah. You're right. So then I'll split it up into 5, and then I'll go sec x tan x times sec x cubed. Um.
Dx
Oh yeah, dx of course.
equal to 15 over 5. No, no. Ah, yes.
And
Yes.
then we can make that 5 times.
You shouldn't put this equality sign here because we have
Oh,
already
so
defined it. Okay, okay, do it, no
so you
problem.
just start on your line. You just start on your line, or sec x to the power 4/4, right?
Yeah, yeah.
Equals 15 over 5.
But you should put limits here from 0 to theta. This is a definite integral.
Oh yeah, you're right.
There
So
are limits.
to, to 0. If we 5 times this over 5. So if I divide both sides by 5, I can make this like that, right?
Yes, yes.
And then if we move on, okay, so sec over 4 minus. Oh wait,
Yeah, yeah.
yeah, sec of 0, sec cubed of 4 quadrupled to the power 4 over 0 over 4 equals 15 over 25. Can I use my
Okay,
calculator for this?
okay. That is fine. What is the value of sec 0? You will put it here.
What's the value of sec 0?
It is 1.
Oh, so this is just 1 over 4 then.
Yes, yes.
Um, okay, so then we add 1 over 4 to the other side. Um, so you end up with 15.
Just use your calculator.
Mm-hmm. And then times that by 4.
Yes.
So you end up with sec 4 theta equals 17 over 5.
Okay.
Um, do I need to get rid of the power at any point?
Yes, yes.
Can I just keep like root for it?
Yes, yes. Take the fourth root.
Okay,
You can
fair
take the
enough.
fourth root.
Um,
What is the value?
okay, so 1 over cos theta equals 1.358,
Why 1
and
over cos
then
theta? Just put sec theta.
okay, yeah, it just makes it a little bit easier for me. Um, usually,
Then, then take sec inverse from calculator.
yeah. So 1 over, then the answer should be 0.743. Okay, that should be the answer.
Is your
Oh,
calculator
it's been,
is your calculator in radians measure? Set to radians
it
measure
is.
or not?
Yeah. It should be. Yeah, I mean it is. It is.
It is.
Mhm.
So what is the answer? Ze-
It should be this.
0.743.
Yeah.
Okay, that's fine.
Should I check it in the
I
book?
Yeah, yeah. That is an example in the book. I couldn't check the answer.
Oh, then.
What is that?
Mhm. Um, what section is it?
11.4.
Ah, okay. Oh, this topic is huge.
Mm-hmm.
Um. Oh,
What happened?
I made a mistake somewhere.
Okay, what mistake?
Uh, if we go, if we look at the actual example,
Hmm.
11.
11, 11,
Oh, it uses a different method.
different method. Method cannot be different. So where did you left it? Where did we left it? Was this correct? This line was correct or not? Here.
I think so.
We have reached,
That
I
was
think this
no,
we
no,
have
no,
reached
no, no, no.
this point.
Have we?
What is mistake then? You
Um,
also reached to this point or not?
I mean, if we hang on,
That is the same. That is same. What is the
yeah, but
mistake?
my number on the other
This
side is different. I think.
this should be 4 using your calculator. Check it again. Why that was a different number on the
Four.
right hand side? This should be 4 on the right hand side, not this whole. This is incorrect.
Yeah,
So you have made some calculation mistake.
yeah. So this is 3/5, but then hang on, 3/5.
So there was a mistake. I don't know where, but you did some mistake here. So if sec
Mm-hmm.
4 is equal to this, then sec theta is equal to plus minus square root of 2.
Mm-hmm.
So take inverse of this. Sec inverse, what is sec inverse square root 2? And what is sec inverse negative square root of 2? Use your calculator.
Yeah. Sort of. Oh wait, my calculator doesn't have
Sec inverse,
sec.
right?
Yeah, it doesn't have
So,
second, but maybe
okay,
that's what I
then
read wrong.
so you can write cos theta equals to 1 over square root 2 and take cos inverse of 1
Hmm.
over square root 2. What is that?
Yeah, 1/4 pi, so pi/4.
So this is pi over 4. What is cos inverse negative 1 over 2?
3 pi/4, which is out of the range.
Yeah.
Mm.
3 pi over 4 and many other equivalent angles as well here.
Yeah. Hmm.
So the correct answer is pi by 4. You can view this in detail and find there may be any other number,
Hmm.
but there is not actually. There is only one theta which satisfies this condition.
Yeah.
That theta should be between 0 and pi by 2. This was the condition given to us. So I think it is everything is clear. Now we will
Yeah.
discuss exercise 11D in the next class on
Hmm.
I think Wednesday.
Yeah.
So see you.
Yeah.
Thank you. Thank you
Thank
so
you
much.
too.